Questions 44, 45, and 46 all relate to the same figure. Question 44 has to do with a line of symmetry. Now, a line of symmetry is a line through which you can fold the figure and have the same thing on both sides. Any line through the center and through points of either the yellow or red pieces are lines of symmetry here. There are 8, which is answer H. Question 45. The diameter is 2, so the radius is 1. You must know the formula for the area of a circle, which is A equals pi r squared. Well, r squared is just 1, so this is pi. A equals pi, which is approximately 3.1. Answer A. Question 46. The new panel is 75% longer. 75% of 2 is 1.5. Simply add 2 and 1.5 to get 3.5. Answer J. Question 47. Since lines AB and CD are parallel by the properties of parallel lines cut by a transversal, any two angles are either congruent or supplementary, which means they add to 180 degrees. The angles BAC and DCA are clearly not equal. They add up to 180 degrees. Lines AE and EC bisect those two angles. So angle CAE is half of angle CAB. Angle ECA is half of angle DCA. So the sum of angles EAC and ECA has to be half the sum of angles BAC and DCA. And remember, they add up to 180. So EAC plus ECA is 90. And AEC, angle AEC, has to be 180 minus 90, which is 90. Answer C. Notice in question 47 that they have given you the measure of angle BAC. It's actually irrelevant. Angle AEC would be 90 degrees regardless of what angles BAC or DCA are. Question 48. Triangle PTS is an isosceles triangle because two of the sides are radii. So angle RTS is 30 degrees, and it is an inscribed angle in that circle. Here's the rule about inscribed angles. The inscribed angle is half the degree measure of the arc that it cuts off. So arc RS is 60 degrees, twice the measure of RTS, angle RTS. Remember also that the central angle is equal to the arc that it cuts off. So angle RPS would be equal to arc RS. So the central angle there, RPS, would be 60 degrees. The answer is 60 degrees, answer H. Question 49. Two linear equations have an infinite number of solutions only when they can be reduced to the same equation. Multiply the first equation by 3, and you'll get 6x minus 3y equals 24. That means that 24 has to equal 4a in order for these to be the same equation. Solving 4a equals 24 gives you a equals 6, answer B. Questions 50, 51, and 52 all relate to a graph. Question 50. The vertical scale is large frames, and it doesn't go below 2. So Marcia makes a minimum of 2 large frames per week. Answer F. Question 51. Marcia spent 12 hours to make 4 large frames, because each frame takes 3 hours, and 4 hours to make 2 small frames, because each frame takes 2 hours. So she spent a total of 16 hours making frames and donated $3 per hour, or 48 hours, to the charity. Her total profit is 30 times 2 for the small frames, plus 70 times 4 for the large frames. The The total is $340. To get the percentage that she donated to charity, simply divide 48 by 340, which is about 14%. Answer C. Question 52. According to the graph, Marcia can make at most 8 large frames or 9 small frames. Her maximum profit comes when she makes all large frames, so the most she can make is 8 times 70, or $560. Answer J. Question 53. The determinant here is x squared minus 8x, and we want that to equal negative 16. So our equation is x squared minus 8x equals minus 16, or x squared minus 8x plus 16 equals 0. This is a perfect square. It's quantity x minus 4 squared. So this has only one solution, x equals 4. Answer E. Question 54. This is a very simple problem. Don't get confused by the I. This question has nothing to do with imaginary numbers. Simply solve for p by dividing both sides of the equation by 1 plus 0.01i quantity squared. When you do that, you get p equals a divided by 1 plus 0.01i quantity squared. Answer K. Question 55. This is a must question, so it has to be true for any number. Compare this with could questions, where you only have to find one number that makes it true. Since x over 3 is positive and y over 3 is negative, C has to be true, because you're subtracting the same quantity. You could take answer C, add positive 5 to both sides of the equation, get x over 3 greater than y over 3, which has to be true, because x over 3 is positive and y over 3 is negative. Question 56. This is actually kind of a trick question. If they don't give you numbers, you're always entitled to pick your own. The problem should work with any numbers. Now, they've only told you that these are triangles, with sides x and y and the given angles. They haven't told you anything else. So you are entitled to assume that it will work with x equal y. If you draw the heights from the vertices B and Q to the bases AC and PR, you'll divide each of these triangles into 2 triangles. And you can see that each triangle has angles 55, 35, and 90. And they all have hypotenuses that are x, which is the same as y. So each of these triangles divides into 2 triangles, and all 4 of the triangles are equal. So the 2 triangles that we have here have to be equal. If the area of triangle ABC is 30 square centimeters, then the area of PQR also has to be 30 square centimeters. Answer J. Question 57. This is another tricky one. This one is really tricky. The letters that they gave you in the law of cosine are not the same ones as in the question. If you relabel the figure so that angle A is now angle C of the law of cosines, then A and B are 12 and 18, and side BC corresponds to side small c. If you apply the law of cosines and then take the square root of both sides, you get answer E.